So today our topic is 12.7 on page 864. And I've got a little piece of dental floss here. And I put some dental floss on your table in front of you because problem number 1 says, determine if the line is a good representative of the data. And you remember it when we had that scatter plot up here and we took this yardstick and put it up there and we messed around with it till we all agreed where the line ought to be? Mm-hmm. So on page 864 for problem number 1, I want you to just take your dental floss and ignore the red line and put it on there where you think it ought to be to separate the little dots evenly on both sides. Have you put your dental floss on there?
One is not.
So you're saying just looking at 1 says that red line is in the wrong place.
Yep.
Okay. So let's look at 2. I'll take my little piece of dental floss and put it over here and see, I think for number 2, it looks like there's too many dots underneath. So when I put my dental floss and try to line up the things underneath, I got those 3 dots underneath that line that line up, and that is 3, 4, 5, 6, 7, 8, 2, 4, 6, 8.
Yep.
So it looks like that line's just a little bit high, doesn't it?
Mm-hmm.
If you put your line on those little 3 dots right below it. So I would say, no, that's not a good line. But guess what the answer key says?
It's a good line.
It's a good line. So sometimes it's going to be a judgment call. Let's look at number 3. Put your dental floss on there. See, I'm looking at number 3, and just like when I first look at it, I think there's too many dots underneath. So I put my dental floss on there and try to run it through some dots where it looks like it's about even. And then it's like, okay, my line is kind of lining up with the red line. It's just a little bit lower. You follow what's going on?
But if it's kind of the same angle, they normally say.
Then if it's kind of the same angle, then the guy who wrote the textbook is saying it's probably a good fit. Even though I think it ought to be a little bit lower. Of course, I should say, what do you think? Because the other day, when we used when all of us together agreed where to draw the line, what happened when we calculated the regression equation?
It's pretty close.
I mean, we were very close. Number 4.
That's not.
Yeah, I don't even have to put my dental floss on there for number 4, do I? It doesn't even come close. So it looks like we've done the first part of your homework. Carissa, are yours the same? Are your problems like this?
Yeah.
Same problems? Okay, so does problem 5 through 12 say which kind of correlation would you expect for number 5, the length of a person's leg and the person's height? Good. So if it's got the same problems, we're on the same page. If you have a different one, just speak up and, and we'll talk about it. So let's just do number 5. Now, when it says which kind of correlation would you expect, on page 856, it mentions 3 kinds of options for correlation. In other words, it's like there's 3 possible answers. There's on page 856, there's a positive correlation, a negative correlation, and no correlation. Any idea what positive correlation means? Well, look at page 856 and see if you can figure out what positive correlation means.
When it's trending upward.
And what's negative correlation?
When it's going down.
And what's no correlation?
Just no particular pattern.
It doesn't go up and it doesn't go down. It's just like a flat line, isn't it? So, question 5. What would you expect for the length of a person's leg and the person's height?
For them to correlate positively.
Why?
Because positive means up.
The longer the leg, what?
The taller.
The taller the person.
Unless they have really long legs but have a really
And can you
short
see how that one would go up? As if you make an X and Y axis, as the leg is longer, the height is going up. So what about number 6? Outdoor temperature and the cost of air conditioning.
That'd also be positive.
Because as the temperature goes up,
So it's
the cost of air conditioning goes up. What about number 7?
But for the most part.
I know.
A student's weight and their score on a math test.
it shouldn't.
No
No
correlation.
No correlation. One time, I actually decided to collect some data on that.
Oh no.
Was there correlation?
There seemed to be a little bit.
Whoa.
I thought, isn't that it? I mean, I just thought there'd be no correlation. So we'll check it out and see.
Yikes.
Does that mean that we have better or worse?
And I thought, isn't that something? Number 8,
We're average.
a person's salary and the cost of the person's home. As the salary goes up, probably the cost of the home they live in goes up. So what would that be? A positive correlation. Number 9. A little science question. Altitude and atmospheric pressure. Do you remember that from science class?
I mean, the atmospheric pressure is going to go up as you go higher, right?
Okay, if you put a balloon full of helium
And you send it up.
and you send it up,
It gets
does
up
the balloon get smaller or larger?
larger.
Because the helium is expanding inside the balloon.
Mm-hmm.
So when they have the helium in the balloon here on at the Earth's surface, and they let this thing go, and it goes float and clear up into the atmosphere, the higher it goes, the bigger it gets, because if you pack all the air in the atmosphere up, okay, think about the water in the ocean. Is there more pressure up at the top of the ocean or down at the bottom of the ocean? Because of all that water on top that's pushing down on it. So with the air, is there more pressure at the top of the atmosphere or at the bottom of the atmosphere?
Would it be the bottom?
Yeah, it would be.
Yeah.
Same as the water.
Hmm.
So it'd be
So-
why does the air? Oh, the air gets lighter as you go.
So as you go up, atmospheric pressure goes
That
down. What kind of correlation would that be?
negative.
Negative.
Would 11 be both positive and negative?
Or would it be no correlation?
Student scores on college aptitude tests. So you take a test to see what your aptitude is for succeeding in college, and you make a high score, and your GPA from high school. Who's going to do better in college? The person with a low GPA or the person with a high GPA?
High GPA.
Would the high GPA probably have an easier time making higher grades in college?
Yeah.
And if they gave you a test that said, what's your aptitude for college? And you scored high on that aptitude test, then that would mean you'd probably make better grades in college. So the higher your score on the aptitude test,
But if you got a lower score on your aptitude test, then your likelihood would be lower, right?
then your GPA would probably be
So
lower.
is it a positive or negative
So
correlation?
watch. So if here's GPA and here's a scholastic aptitude test,
Uh-huh.
if it's high up here and it's high out here, then that's and if it's, okay, yeah, so we'll put here and here, okay. Then if it's low here and it's also low here, and if it's medium here and it's medium here, then what kind of correlation is that?
Positive.
Does that make sense? If this is low and this is low? So that would be a positive correlation. Number 10, the weight of your automobile and the miles per gallon you get for fuel. You probably don't know anything about that, do you?
Speed. Wait, which one?
Okay, but let's think of it this way. Take a great big truck that hauls stuff.
Mm-hmm.
Will the truck get better miles per gallon? Will it get more miles per gallon if it's
No.
empty or if it's loaded with stuff?
It was empty.
If it's empty, it'll get more miles per gallon. If it's loaded with stuff, it takes more gas to move all that stuff down the road, so it gets less. So would that also be true for the weight of a car? The heavier my car,
Mhm.
the heavier my car, okay, let's just draw another little picture here. Miles per gallon and the weight of my car. So I've got a real heavy car, and that means I get what, low miles per gallon?
Mm-hmm.
So that's right here. Wait a minute. That's right up here. And then I have a light car that gets high miles per gallon. So that's right over here. I have a medium car that gets medium miles per gallon. So that's right here. So what kind of correlation is that?
Negative.
Because as the weight goes up, the miles per gallon go down. So that's a negative correlation. Number 12. The speed of your car in the miles per gallon. Do you get, now we've got miles per gallon and speed. So if I'm going real fast, does that push my miles per gallon up or pull them down?
I don't know.
You don't know. Well, it pulls them down.
Hmm.
So if I'm almost out of gas in my car Should I drive 70 miles an hour to hurry up and get to the gas station? Or should I drive 50 miles an hour so I'll go further down the road looking for a gas station? If I drive slower, say, why would that be? Okay, think about it. When you're driving fast, you're hitting a lot of wind, a lot of atmosphere real hard. When you drive slower, there's not as much atmosphere you encounter to create more friction that you're driving against. So if I'm going slower, my miles per gallon are out here. So that would be, again, what would that be? A negative correlation. The higher the speed, the lower the miles per gallon. Number 13 through 20. Select a phrase that correctly completes the sentence. The value of the linear correlation coefficient is always, that's on page 859. Look at page 859. You say, I don't know anything about the linear correlation coefficient. It's called R. Well, look at page 859 and you'll learn something about it.
Oh my goodness.
Are you ready to, and you see, once we get through talking about this stuff and it makes sense, then we're going to learn how to calculate correlation coefficients. You know how we learned how to calculate standard deviation and then calculate a linear regression equation? Well, now we're going to learn how to calculate correlation coefficients. But before we do that, number 13, which answer is the correct answer? A, B, C, or D for the value of the linear correlation coefficient is always close to 0, close to 1, between -1 and 1, inclusive, or it's always positive. Look at page 859 and guess which one of those four choices you think is right. 859.
It's between -1 and +1.
Because that's what it says, doesn't it?
Mm-hmm.
It says the correlation coefficient is always between -1 and +1. Number 14. The linear correlation coefficient measures A, a cause and effect relationship, B, whether a scattergram shows interesting patterns, C, whether two variables are related, or D, the direction and strength of the linear relationship. Look at page 860. So for question 14, look at page 860. What's the correct answer for question 14? Based on page 860.
Direction and strength
Of the
linear
linear relationship. You get a what? Okay, let's look at A, a cause and effect relationship. If you have a high GPA in high school, you'll probably be more apt to have a higher GPA in college. So does a high GPA in high school cause a high GPA in college? Or do they just correlate?
No, they just correlate.
They correlate. You see that? It doesn't cause it. And the reason he puts that choice there is when you take your class on what is that called? Test and measurements? Correlation does not indicate causation. whatever caused you to get a high GPA will probably be the same thing that causes you to do to get high grades in college, but the high GPA doesn't cause it. There's just a correlation between the two. So it's important to understand that distinction. Number 15, a linear regression line. You remember that thing we did for all those dots? That scattergram, and we calculate the linear regression line, is computed to predict the final exam score on the basis of the score on the first test. Suppose Maria scores a 90. We've got to write this up here. It's getting to be too complicated. What does it say? Number 15. A linear regression line. Oh, it already calculated for it. Y equals 10 plus 0.09x. Y equals 10 plus 0.09x. Everybody follow that? They've already told us what the regression line is, haven't they? The regression equation. And they're using that to predict the final exam score on the basis of the first score on the first test. And let's say Maria's score on the first test was 90. So her score, I'll change colors here. Her score was 90. Well, that one's no good. And why is it in there? I don't know. Her score was 90. Okay, that was her score. So, what would be the predicted value of her score on the final exam? Which is this. What would that be? What's 0.09 times 90? Calculators?
91.
90 times 0.09 equals, what's it say?
8.1.
I can't, this
I
thing,
might have done it wrong.
90 times 0.09
Yeah, 8.1.
equals what?
8.1.
Okay. That thing doesn't print the decimal, so 8.1, right?
Oh, isn't it supposed to be 0.09? The book says 0.9.
Oh, it does?
Uh,
I was confused why I got it.
You're right, it does.
like, oh, what is happening? It's
How can I-
81. It is 81.
I was like, no.
0.9. So how can I, so now I take 0.9 times 90 and what do I get?
81.
81. If I copy it down wrong, plus 10 equals what?
91.
So what do we predict her grade will be on the final exam?
91.
91. Number 16. The scattergram shows the calories. See, if we're doing your assignment in class, don't you think it's only fair we do the even ones too? The scattergram shows the calories and the sodium content of several brands of hot dogs. On the basis of the least squares regression line, which is shown, so that's that red line, a hot dog containing 100 calories, go across the bottom to 100 calories, go up to where it crosses the red line, and how many sodium would it have in it? Almost 375, wouldn't it?
Yep.
So I'd say what, 373?
Yeah.
That's not one of the choices.
350.
So if my only choices are 70, 350, 400, and 600, what are you going to choose?
350?
350. It seems to be a little far away, but if it's one of those four choices is the correct answer, then I'm stuck with one of those choices. Number 17, the scattergram shows the amount of carbon monoxide and nitrogen oxide emitted in the exhaust of cars per mile driven. So on the basis of the scattergram, that's the red line, and the least squares line, that's the least squares line is the red line, predict what a car emitting 10 grams of carbon monoxide. So I go up to 10 across the bottom, go up to where it crosses the red line, and what number do I have on the nitrogen oxide side? It looks like 0.9, doesn't it? In terms of where the red line is drawn? Is that one of my choices?
No.
So what's the closest choice to 0.9?
1.1.
There you go. It kind of looks like when they printed this book, the red lines kind of fell a little bit out of sequence. But if you understand how printing works, you'll understand that, won't you? That the paper goes through once to get it one color, and then it goes through again to get the next color. So if it's just a little bit off. Number 18. Well, there's a scattergram for height and volume. Does it say what it's talking about?
Nope.
No.
But
So
there's
does
a-
that mean how tall you are has something to do with how much water you would displace in a bathtub?
Sure.
Your volume? You know, if you say put a tall person in a bathtub, how much water do they displace? How much volume do they have? I don't know, but if I just assume that, so here's how tall a person is and here's how much volume they have, then what is this little black line here? Is there a black line there? Or did I draw that into my book?
I think you drew that in.
Does yours have a line in it?
No, but it looks like it's positive.
Well, then get your dental floss and put it on there and try to find a line that looks like a good fit in between those dots. Do you have a line yet?
Yep.
Then take your pencil, and you don't have a straight edge with you, take a piece of paper and fold it twice, and there's your straight edge, and draw a little line. Now, here's the choices. Now that we've drawn a line in there, does it look like it's a positive association between height and volume, a negative association, or neither? Or no association? A, B, or D? Because those are the three things that we have. A positive association, a negative association, or no association. And if it's going up like that, what does that mean?
Positive.
Positive? Is that what everybody says?
Mm-hmm.
When one goes up, the other goes up, so that's positive. Number 19, a plausible value R for the correlation between vehicle weight and miles per gallon is, yeah, I didn't draw a line here, so I have to get my dental floss and put it up here. Put it there between those red dots to make a regression line, and what do I say? Well, I know it's negative, don't I? Does everybody understand that when I put the little dental floss there, I know it's a negative correlation?
Mm-hmm.
So now I have two choices for negative. Negative 1 or negative 0.9. And what do we say about correlation coefficients, that R value? It'll be a number between negative 1 and positive 1.
Mm-hmm.
But if it was negative 1 exactly, you know what that would mean? All those red dots would be on the line. Because negative 1 would be a perfect correlation. That would mean all the red dots are right on the line. So what does it have to be?
Negative 0.9.
Negative 0.9. You see how doing these exercises helps you fix this concept in your head? And if you were doing this on your own, you'd go, why is that the answer? What's wrong with -1? Because -1 would be a perfect, where all the dots would line up. Number 20. No, let's skip that one. Number 21. Do people of similar heights tend to date each other? One of the women in the dorm said the woman is 65 inches tall and the man she dated was 71. The woman was 63 and her date was 67. Another woman was 65 and her date was 69.
Oh, I thought these were ages. These are,
Who
That's
collects
like,
information
wow.
like that?
don't know.
So, what does it look like? As the woman's height goes up, what happens to the man's height?
It also goes up.
So what would that mean?
There's a positive correlation.
There's a positive correlation. Well,
Is
it
there
looks
just
like
a positive correlation, or is there a strong positive?
Yeah. Like, well, there's looks good.
But it says since the men are always taller than the women they date. That's
yeah. So
really
see,
high.
But the
Always.
second number B, letter B, says there is a strong positive correlation between the heights of men and women, since the women are always smaller than the. Oh,
And
I
D
see what you
says
mean.
because
It's the
they're always
opposite.
taller, and
Yeah,
C
so
just
it has
says
to be
there's.
So is it just C?
That's weird.
Maybe. Why did it say it like that?
what
So-
do I have to do?
if you said always, boy,
Yeah.
that would be a perfect,
Okay,
wouldn't
so
it?
that's-
And you say, I'm not sure I can say always based on 5 subjects,
Right.
so I better go with
Okay. So
C. There's a positive correlation. But the sample size was so small, we can't make too much noise about it. Because isn't that what happened? I did a survey in class, and I understand you ladies at lunch talked about it and concluded that my conclusion was faulty. Here it is. See, there's a red jacket and there's a red jacket,
Really
so
good
guess
at it.
what? So that's 2 out of 3 women on campus are wearing red jackets today. Let's see if that holds up when you get to the cafeteria and eat lunch.
We'll check it out.
This is in class.
I mean, don't you find yourself just sometimes inclined to check this stuff out? And by the way, when you become teachers and you're teaching this stuff, sometimes the problems in the book don't necessarily relate to life, but do you see how you can have your kids doing some of this stuff in real life
Yeah.
and actually having some fun with it? To think that you were eating lunch and thinking about math class. That has to be so cool to me as a teacher. Okay, enough of that. Let's keep working. We got to get this stuff done. We're skipping 22. I'm not talking about beer sales. Okay, now we're ready for the second part, and it looks like that's the whole rest of your lesson. In problems 23 to 30, make a scattergram for the data. Remember the little chart? Find an equation of the regression line. You're going to use the formula or go to the easycalculation.com.
So which one do we want to do?
Let's see. That's a no-brainer, isn't it? Find R, the correlation coefficient. The formula is back here on page 863. Example 6 shows you how to calculate it. And then D, interpret the results of R in accordance with table 12.27 on page 859. You go, what's on 859? Table 12.27. There it is, table 12.27. Interpreting R at the bottom of page 859. Find R, then go to line N in the table. If the absolute value of R is greater than the number in the column labeled 95%, we can be 95% confident that there's a significant linear correlation between the variables. Continued, page 860. If the absolute value of R is greater than the number in the column labeled 99% on line N, we can be 99% confident that there's a significant linear correlation between the variables. Let's look at example 4. Find the correlation coefficient on page 860. See how they went through all the table? Remember how you make a table with x and y and x squared and xy, and then you plug this formula in down here, and then on page 861 it says, oh look, R is 0.88. Do you see what I'm looking at on page 861? Okay, now let's go back to the table. Okay, how many women were in this exercise? 2, 4, 6, 7. There were 7 people. So go back to page 859 to table 12.27 and go down where N is 7. Now what was the R value for that exercise? 0.88. You see where 0.88 came from? The top of page 861.
Yeah, I saw it 0.88.
Okay, so the R value was 0.88. Now, we go down to 7. 0.88 is greater than the number in the 99% column. So, I can be 99% confident that there's a significant linear correlation between the two variables. Everybody follow what we did there?
Mm-hmm.
So now we're ready to do the first exercise. So let's do problem number 23. Let's make a scattergram. All right, let's turn this on. Let's erase this. Get this out of the way. Let's go to the internet. Let's make a scattergram. Make a scattergram. Make a scattergram online. I think that's what I want to do, isn't it?
Mm-hmm.
Okay, now see all my choices here?
Mm-hmm.
Create a scatter plot chart. You mean to say that chart we made on the whiteboard the other day, you could have gone to the internet? Did any of you do this for your plots, for your scatter plots, for your assignment, that you went to the internet and found a place where it would actually do them for you?
No, I just didn't.
You just did them. It wasn't that much trouble. Well,
Well, I mean.
the one I'm going to use is down here, because I've done some research before I came to class, and I'm going to use the one by Alcula, Scatter Plot Generator. Online calculators. So you might want to write that down. Scatter Plot Generator at www.alcula. Watch what it says to do. Enter the X and Y values. So for problem number 23, X and Y, whoa, dropping all my cards here. Oh boy, when you get old, you don't want to get down on the floor to pick things up. Okay, problem number 23. I'm going to type in the numbers while you tell me what to type in. What's the first X value?
2,
2, comma, what?
1.
1. Then I hit enter and go to the next line.
4, 3.
4, comma, what?
3.
3. Enter. Next line,
7,
what?
8.
7, comma, 8. Enter.
3, 4.
3, comma, 4. Enter.
1, 8.
1,
1, 2.
2. You have to read it right if you're going to get the right answer. What's the next one?
5, 2.
5, comma, 2. Enter. Then what?
8, 6.
Enter.
10, 7.
10, comma, 7. Enter.
And 6, 6.
6, comma, 6. Enter.
9, 4.
9, comma, 4. Enter. Well, so now I've got all the data entered. What do I punch next?
Maybe submit data.
Maybe I better submit data. Whoa! There's my scatter plot, just like that.
That's pretty fancy.
Just hit print, and you've got that one done. Now watch what it says. See what it says here?
Whoa! It has the correlation coefficient.
Find the equation of the regression line. So I go linear regression.
Whoa.
And there's the regression line. It stuck the regression line in there. And there's the equation. Y equals 1.13 plus 0.57 times x. You follow me? You don't have to write all the numbers out there. Everyone see where I'm getting that? Y equals 1.13 plus 0.57 x. So now I've got because it said find the regression line, so I've just got that equation for the regression line. What else did it say to find?
Correlation coefficient.
What do you think that blue thing will do? Correlation coefficient. Whoa! The correlation coefficient is what?
0.73.
So 0.74. I'm just going to say 0.74. Round it off to those two places. So do you see what you do? You do the plot, and then you can, I suppose, you do the regression line and then print that out, and then that's all you print out is the plot with the regression line on it, and then you just write the other stuff on there, and you've got problem 23 done. Oh no, we have one more thing to do. Interpret the results with table 12.27. So let's go back to table 12.27. On page 859. And how many numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 numbers, right? So go down the end column to 10. And what's our correlation coefficient? 0.74. So see the number under 95%, 0.632. See the number under 99%, 0.765. Everybody see what I'm talking about?
Yeah.
So, where's 0.739?
Less than 0.7.
It's less, so I can't be 99% confident, but I can be what? 95% confident that there's a correlation between those two. And everybody see we just completed exercise 23?
Yeah.
And that's the way you do all the rest of them. You want to do another one?
Sure.
24.
Well,
So let's go back.
25.
Yeah, I know you would, but we'll just go back and go back and go back. Whoops. Scatter plot generator. Okay, now it's still got my plot in there.
Say reset.
Oh, hit reset.
Mm-hmm.
There. What's it say to do? Oh, it's telling me what to do now. It's giving me instructions on what to do. Enter the X and Y values. And now we're looking at problem, what, 20?
4.
24. So can you give me the X and Y values for 24?
Sure.
What are they?
9 and 4.
9, comma 4.
10 and
Enter.
2.
And then what?
10 and 2.
10, comma 2. Enter.
8 and 3.
8, comma 3. Enter.
8 and 6.
8, comma 6. Enter.
6 and 4.
6, comma 4. Enter.
4 and 8.
4, comma 8. Enter.
5 and 7.
5, comma 7. Enter.
5 and 5.
5, comma 5. Enter. Is that it?
3 and 8.
3, comma 8. Enter.
And 2 and 10.
2, comma 10. Enter. That's it?
Mm-hmm.
So click submit the data. And there's my scatter plot. And then click what? Linear regression.
Yeah.
And there's the linear regression line. And the equation, y equals 10.76 minus 0.84 times x. And now, see what it says? Use the linear regression equation to estimate y. Enter a value for x. So do you see where I could enter another x? Like I could put 6 in here.
Mm-hmm.
I could come here where, like where it says 6, I could put 6 in there and calculate the y. And the y is 5.69.
Mm-hmm.
See that?
Mm-hmm.
But the assignment says, what? Now we need the correlation coefficient.
Mm-hmm.
There it is, negative 0.88. So let's go back to the table. Let's interpret the results. Go back to the table. 12.27 on page 859. How many values did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, down the end column to 10. And what do we get? 0.885. Whoa, that's higher than 0.765.
Whoa.
So we can be 99% confident.
But it's negative. Does that matter?
Okay, so we can be 99% confident that there's a negative correlation between these two variables.
Okay.
Does everybody see what's going on?
Uh-huh.
Well, then just work the rest of the problems and you know, stop when you get to 31. 31 will be your last problem.
Mm-hmm.
Now, you know what you can do for number 31? Because, see, this says 23 through 30. It gives you information. for number 31, you can actually take those dots and make ordered pairs for them. Like for the first dot, it looks like it would be 0.5 and 11. You follow what's going on? You could take those dots and figure ordered pairs and plug them in here, and then you don't have to wonder about it. It'll actually calculate it for you. So if you have a graph, you can take the graph and calculate a regression line and then calculate a correlation coefficient using this magic little place on the internet. Why didn't they have this when I was in college? We had to do it all with tables manually. And you know, I'm so tempted to make you do a table just so you'll know what it's like to walk to school. But then I think, why would you do that? Why would you make someone go back and live like you did when you were that age? Because it's just too easy now. Well, that's life. You guys have all these benefits from modern technology. And hopefully, you'll use this stuff when you're teaching your little kids how to do all this stuff. But when I found this one, see, we could use one of the other scatter plots, but I don't think the rest of them do all this stuff. I mean, it's like this particular program was put on the internet just to work problems 23 through 30. And I'm smiling thinking, how many people out there in the world were required to do this and the teacher didn't tell them about that? They just made them do it the old way because that's the way we had to do it when we were in school. Hopefully, you guys will investigate modern technology. My wife hears me laughing when I'm preparing your lessons. She goes, "What's so funny, Tom?" And I said, "Nina, you will not believe what modern technology does for these people. It's just amazing what's out there on the internet." So anyway, that's the assignment.
I have a question from 12.6.
Okay, so I will turn this off and start answering questions.